So have you heard the buzz online, this idea that Earth's magnetic poles are about to flip, maybe as soon as 2026, and that all our electronics are just going to stop working? It's a pretty terrifying thought. Now, while that specific rumor needs a serious fact check, it does plug into a very real danger: solar storms. You see, our entire digital world, everything we rely on, was built during a pretty calm period in space. But right now, the sun is waking up. So the real question isn't about a pole flip in 2026. It's this: when the real big one hits, is our tech ready for it? Let's dig in.
Check out this quote. It sounds like something from a sci-fi movie, doesn't it? Back in 1859, a telegraph operator in Boston sends a message up to Portland. He says, "Hey, my battery's disconnected, but the line is still hot." For 2 whole hours, these guys sent messages back and forth using nothing but the raw electrical power generated in the sky by a monster solar storm. This wasn't science fiction. It was a wake-up call, a preview of the sun's incredible power.
And you know what? This all happened incredibly fast. It started when an astronomer, Richard Carrington, just happened to be looking at the sun and saw this brilliant, blinding flash. A little over 17 hours later, a trip that usually takes a few days, a massive cloud of solar plasma just slammed into Earth. And by the next morning, the most advanced tech on the planet, the telegraph network, was absolute chaos.
That whole incident, which we now call the Carrington event, is basically our best historical blueprint for what an extreme solar storm can really do. It was literally the day the sun reached down and put its hands on our technology.
I mean, the effects were just mind-blowing. The northern lights, the aurora, were seen as far south as Cuba and Colombia. They were so bright out in the Rocky Mountains that gold miners actually woke up and started making breakfast, thinking it was dawn. But it wasn't just a light show. Telegraph pylons were shooting off sparks, operators were getting zapped with electric shocks, and some stations even caught fire. This was a global electrical event.
So what exactly is going on here? What is this fiery breath from the sun that can cause so much trouble? Well, to really get the threat, we need to know the difference between the 2 main ways the sun can lash out.
Okay, so first you have solar flares. Think of those like the muzzle flash from a cannon. They're these intense bursts of radiation traveling at the speed of light, so they get here in just 8 minutes. They can mess up radio and GPS, for sure. But the real danger, the cannonball itself, is the coronal mass ejection, or CME. This is a gigantic cloud of magnetized plasma hurtling through space. It's the CME hitting Earth's magnetic field that can cause the catastrophic damage to our power grid.
So how does a CME actually break things? Well, when that giant plasma cloud hits and rattles our planet's magnetic field, it creates these powerful, uncontrolled surges of electricity in our power lines. They're called geomagnetically induced currents, or GICs. What's happening is that our hundreds of miles of power lines are acting like giant antennas, just soaking up all this dangerous energy from space and feeding it straight into the grid.
And that brings us to today. Look, the telegraph system back in 1859 was pretty simple, pretty robust. Our modern world, it's built on a massive, interconnected, and honestly, a pretty fragile electrical grid. We are way more vulnerable than they ever were.
Let's just put a number on this for a second. A study from Lloyd's of London tried to figure out what a Carrington-level event would do to the US today. The estimated cost? Up to $2.6 trillion. That's trillion with a T. We are talking about widespread blackouts that could last for weeks, maybe even months, because of the damage to the hardware.
And the specific weak point, the heart of the grid, are those giant transformers you see at substations. GICs are basically a form of DC current, and transformers are not built to handle that. It overloads their magnetic cores, causing them to get incredibly hot really fast. This can literally melt the internal components, leading to a total failure of a machine that can take months, sometimes years, to build and replace.
And look, this isn't just a what-if scenario. A recent study dug into years of power outage data in the US and found a direct link. You can see it right here. Within a 3-day window of a geomagnetic storm, the risk of a big, unexplained power outage more than doubles. The data is pretty clear. Space weather is already making our grid less stable.
But it's not just about that one big knockout punch. There's also this slow burn problem from smaller, more common storms. They inject enough current to cause transformers to heat up inside, which slowly degrades their insulation. Think about bending a paperclip back and forth. Each little bend weakens it, until one day, it just snaps. These moderate storms are doing that to our grid, slowly making it weaker over time.
Okay, so beyond the power grid, there's another, kind of sneakier threat that affects every single digital device we have, from the phone in your pocket to the computers flying our planes. And this threat comes from cosmic rays.
So imagine a single high-energy particle from deep space zipping down and hitting a microchip just right. It can flip a tiny bit of data from a 0 to a 1 or a 1 to a 0. This is called a soft error. Now, it doesn't break the hardware, but it can make your software crash, corrupt your files, or cause a critical system to make a really bad decision at a really bad time.
And where you are matters a lot. Our atmosphere is a pretty good shield, but as you can see from this chart, the higher up you go, the bigger the risk. At the altitude where planes fly, you're getting hit with over 300 times more of these particles than you are down here at sea level. That makes aviation and satellite electronics especially vulnerable.
Now, I know this all sounds pretty dire, but here's the good news: we are not helpless. Scientists and engineers are working on this stuff right now, developing ways to protect our tech from what the sun can throw at us.
For the power grid, there's a really clear 4-step playbook. First, you have to monitor for these GICs in real time. Second, you use alerts from satellites to get a heads up that a storm is coming. Third, we can actually build better protection into the transformers themselves. And finally, if it's a really bad one, operators can do a controlled shutdown, basically turning things off for a little while to save a priceless transformer from being destroyed forever.
And if you look even further into the future, the solutions get straight up science fiction. NASA is kicking around ideas like this, a deployable deflector shield. It's basically a giant electromagnet that a spaceship could unfold to create its own personal mini magnetosphere, its own force field to ward off radiation on those long trips to Mars. How cool is that?
Okay, so let's circle all the way back to that question we started with. We've seen that solar storms are a real, serious physical threat. But what about this whole idea that the Earth's poles are about to flip upside down and send us into chaos? It's time to separate the actual science from the internet hype.
So the single most important thing to understand here is the timescale. A geomagnetic storm, what we've been talking about, is a weather event. It's caused by the sun. It happens over hours or days. A geomagnetic reversal, a pole flip, is a geologic process. It's driven by the churning of Earth's core, and it unfolds over thousands and thousands of years. It is not a sudden, violent event.
So let's just lay out the facts. Yes, the North Magnetic Pole is moving pretty quickly right now. And yes, the magnetic field has weakened a tiny bit. But the scientists who study this for a living say this is all normal behavior. A full reversal takes, on average, about 10,000 years to finish. So let me just be as clear as I can be. Based on everything we know from geology and physics, there will not be a magnetic pole flip in 2026. The real, immediate danger isn't the slow dance of the poles. It's the fast and furious storms from our sun.
And that leaves us with this one final thought, doesn't it? We built this incredibly complex, fragile, digital civilization of ours during a time of unusual solar quiet. Those telegraph operators back in 1859, they got a warning shot. We now know that a storm like that one isn't a question of if, it's a question of when. So forget the pole flip. The real storm could be coming much, much sooner. Are we truly ready?